me go over to the other
Live
piece.
streaming is on.
Thank you. The countdown has started.
Let me go take a look.
I don't know if you've seen this mug before, Neil, but this is one of the rare ones from CJ's Pharmacy Seeds Network. How about that?
I have to come up with my own, right? I don't know, my wife runs around with a license plate frame that says, "If you don't talk to your cat about catnip, I will."
All right, so that's live streaming.
Yeah, I'm just double checking.
Yeah.
And then once you give me the thumbs up, I'm going to mute everybody and then kick us
Well,
off.
it's just about to. You can click on timer if you want.
All right, I have a shareable link. All right, I put that in the chat, and I'm also going to post it on the OMARC page.
You're not having it.
And do you want to leave that open in case people ask questions before on the YouTube live stream? They can ask in the chat here. So just, you know, keep that window open when we get to Q&A later. I'll let you moderate the YouTube questions.
It took a picture from another live session. I'm sorry about that as the thumbnail. I'll see if I can edit.
All right, I'll see you guys later.
Okay.
Okay, thank you.
Bye.
Bye. All right, so
Neil, I'm going to put everyone on mute now since I think people are going to start popping in here. So I'll actually kick us off at 8:03 if we're all on the team, same clock. So 8:03 is when we'll officially get underway.
All right.
All right.
I'm going to change the thumbnail, and then we're good.
Interestingly enough, Neil, when you do a live stream, it doesn't let me record it because then that would be duplicitous. So we're reliant upon you. So don't crap out your internet. Otherwise, we lose the recording. All right, so I'm going to kick us off in about another 35 or so seconds.
It's very military of you to start with a T-2.
All right, putting everybody back on mute. All right, well, good evening, everybody. This is Steve, K2GOG, and welcome to the May 17th iteration of HVDN Live. Tonight, we're broadcasting live on the W2NDG Science and Technology channel. So for those that are not able to join us tonight via the open source video platform Jitsi, we are also live streaming over YouTube, and that's where we're going to post a edited recording of this following this evening's presentation. So I'm super excited to be joined by Nolan, KE8JCT, who is going to be sharing quite a lot of information about the United States Military Academy at West Point's 11th high-altitude balloon launch that took place latter part of last month. And before we go to Nolan, just want to share a couple little brief bits of information. We have the Hudson River Radio Relay event coming up on June 12th. Details are at the website hudsonriverradiorelay.com. There's lots of exciting things going on with that event. As part of that, I'll highlight that USMA is going to be one of the 8 stations that's going to be participating to help raise awareness and support for Bannerman's Island. The USMA team are going to be operating under the call sign from Constitution Island under November 2 Delta. So there's going to be quite a lot of really fun activity on the air that weekend. Aside from Constitution Island, myself and a few others that are HVDN supporters will be on Bannerman's Island under the call sign November 2 Bravo. So for anyone interested in making contact with some first time ever stations, it's Rare DX right here in the Hudson Valley. So further details, you can check that out on our website, hudsonriverradiorelay.com. So with that, I'm going to go through a pretty quick intro with Nolan, and then I'm going to turn over the presentation for him this evening. So Nolan, welcome to HVDN Live. Thanks for coming aboard. How are you this evening?
I'm good, Steve. Yeah, thanks for having me.
Fantastic. So for those that are not familiar, USMA at West Point is one of many clubs representing the amateur radio community within the Hudson Valley. And there's quite a lot of exciting things going on at USMA from an amateur radio perspective. So Nolan, would you like to share a little bit about yourself? You have a pretty interesting background and your blog, and obviously what you're going to be helping support the country through. So why don't you tell the audience a little bit about yourself?
Yeah. So I'm Nolan, KE8JCT. Tomorrow, actually, I'll be N2 Whiskey Uniform, put in a call sign request. But I'm an electrical engineering major here at West Point. I kind of specialize in telecommunications, all things radio frequency. I'm also a space science minor, so a lot of CubeSats, a lot of experimental satellite work is really what I like doing. So I'm president of the Amateur Radio Club here, W2KGY, Whiskey 2 Kilo Golf Yankee. I'm also president of our Astronomy Club. So obviously our big overlap there, which I'm happy to talk about tonight, is our balloon satellite and our ham radio tracking. So I'm involved a lot. I do triathlon here also. There's just so much to do. And I really like training and educating people about radios. We always use radios in the military. Nobody really knows how they work. They know that they break a lot. So kind of educating more, throwing in some more HF knowledge into everyone to have that in their toolkit as a future officer. That's really where I like training the Corps. I conduct a lot of trainings. We do a lot of direction finding fox hunts because that's something that you can use in the field too, to really educate and license and spread the word about amateur radio here at West Point. That's really my goal.
Fantastic. And so, speaking of radios, it looks like you have quite a interesting collection of things there in the USMA Cadet Radio Club. Care to share a little bit of a tour?
Yeah. So I won't move the camera or anything. I'll just stay here. If my perspective is right, so this gray one right here at Collins S line, the date on there is 1962, I think. And then the Heath kit down there below it, the SB 101 is what it is. So those are actually both fully operational. We repaired the tubes on them last year of the capacitors because they blew out. So they should be fully operational. We also use it kind of as emergency preparedness toolkit. They should work when there's an EMP blast because of the tubes. So we have those also in case of emergency communication. I'm standing right in front of our PRC 150 in a kind of Humvee mount that we have right there. So we use that for ALE when we communicate across really the Western Hemisphere with all sorts of different military stations from Canada and Brazil and Mexico, of course the US also. So, and then we've got an ICOM and some computers that are capable of digital modes. Our APRS iGate is also right there. You can't really see our satellite station because I'm standing right in front of it. And our Flex Radio 6700, our Maestro, our mid JK Tri 40, and our PGXL amplifier. So we have a very nice station here. We're really grateful for all the donors that we've had. But we have a lot of people who enjoy amateur radio, and they get to use this equipment to its fullest.
Well, it certainly is an impressive shack by no means. I'm not in front of my shack, so I have a much more sparse background compared to yours. So very, very cool to see such a range of new and old equipment.
Yeah. Well, Steve, I do see that you got a spectrum graph, I think, behind you.
Yes, good eye on that. So my perspective, it's either somebody's to the left of my fat head or to the right. I don't know which, but
yeah,
that spectrum chart, some might see it as the familiar FCC way of how they kind of visually recognize spectrum. But this particular chart is actually hand-drawn by one of the artists in residence at a local radio station, WGXC Waveform Radio. And we're actually using this spectrum chart, which is a limited poster print to help support the Bannerman's Island special event coming up. So if anyone wants to support not only one great cause, but two, so you can support the radio station, which is quite the interesting place. We'll paste the link in the replay to Waveform. So part of the proceeds go to them, and the remainder of that goes directly to Bannerman's Island Trust. So it's a cool thing. You can see the details for that on the Hudson River Radio Relay website. So thanks for pointing that out. Is there anything else interesting in my background, or is that the only thing that caught your eye?
Someone way to the left of you, and it looks like an award of some sort.
To the left. Oh, like.
Or to my left.
Oh, to your left. Oh, that's like a static. Talking about satellite and space. That's a kinetic sculpture. So if I start moving it, the magnet in the base contacts a electromagnet that is very weakly powered, and until that D battery runs out of juice, it'll just keep doing its thing. So I don't know how long it'll last, but it's super annoying. If I let it go, you see it just builds up momentum and it just keeps doing its thing. So yeah, that's what that is. And I'm gonna stop that in a moment. But great, and again, thanks for coming aboard. So I figure the approach for tonight is, take us through your slides, which are fantastic and full of information. If anyone has any questions, I'm going to put everyone on mute for the duration of this, so everyone please respect that. Don't come off of mute and be a disruptor, but do feel free to type your questions into chat. You could either do so on Jitsi, or you could also do on the YouTube live stream. And then after Nolan takes us through about 35 or so minutes worth of material, we'll come and do some Q&A. And so figure it's 8:11 Eastern time now. We'll probably run till about close to 9 o'clock, maybe a little over, depending on questions. So that'll be the format. And with that, Nolan, I'll turn it over to you. I'm going to mute everybody, and then you can initiate the screen share on your end.
All right. Let me see. Does that work for everyone?
It does. And so just a quick heads up, when I hit mute, it's going to knock you out. So just bring yourself back from mute.
All right, still here, everybody, Kior said? Am I? Hold on a second. And I'm back, all right? Everybody can hear and see me okay?
Yep, we got you. So I think if you hit the, yep, there you go. Now you're full screen, so that's perfect.
All right. Well, thank you all for coming. I'll go ahead and talk about our Astronomy Club AY21 academic year balloon launch. So our big thing here is cross-organization. So West Point Amateur Radio Club, the USMA Astronomy, the SMDC, and then Army Cyber Institute. So it's a big conglomeration of all these different efforts. So I'll go into a little bit of background about the Ham Radio Club. We're actually the oldest club on post, continuously run. Equestrian team is second place behind us. In 1932, our first call sign was W2JIG. And we licensed about 10 to 12 cadets per semester with Laurel, so it's free and it's really cheap and it's online. And then our big angle is combining ham radio with military training. So we've always heard fox hunts and HF usage and ALE. So that's our big angle, is we stress and organize and train cadets on how they can use that as future officers in radio training. Like I said before, a very impressive station. Satellite tracking rig, ICOM 9700. Our different flex radios and the Maestro over there with the PGXL. Our mid-tri 40 on the roof. Our M2 satellite array. So it's a lot of very nice equipment that we're able to use. Probably one of the best in the country for college stations. And so if you see that on the top right, that was our picture in the club 2019. After we talked to Colonel Drew Morgan when he was in the ISS over voice. Turns out if they're alumni of the school, you kind of just get an in with them. And if they were in the same company as your officer in charge, they seem to know each other a little bit better. So a little bit about me. I'm Cadet Nolan Pearce. KE8JCT is my call sign. That's still a 2x3. I put in for 1x2 and 2WU, and I'll be getting it actually tomorrow. So I've been a ham since 2018, licensed in Cleveland, Ohio, where I'm from. Electrical engineering major, space science minor, telecommunications. I'm in charge of both the Amateur Radio Club and the Astronomy Club, so like all things space and all things radio. I'm also on the triathlon team, so I'll often track my bike on APRS, which is a lot of fun. And then with ham radio, I really like Summits on the Air. I really like Morse code and CW, and then a lot of QRP interests. And I have a website, ke8jct.wordpress.com. That'll change in a little bit. Once I get my new call sign, that'll probably just switch to N2WU as well, but I put a lot of projects on there for everything technology and ham radio that I work on. There was me with Bob Berninga at a conference one time. We're learning about APRS touchdown. That was a lot of fun. So just to give you guys the greatest overview, so the Astronomy Club and the Amateur Radio Club designed, built, tested, and launched our 11th high-altitude balloon to train cadets on mission planning and conducting that high-altitude research. So it was 14 cadets and 7 faculty. 5 cadets actually had licenses and 3 of the faculty did. So it was great involvement in amateur radio. We did it on 24th of April, launched at about noon in Scranton, Pennsylvania, and landed and recovered at 1500. Flew about 90 miles from Salt Creek State Park in Pennsylvania near Scranton, and then landed in New Paltz and Gardner, New York, right above Angry Orchard. And so we conducted our altitude research, talked cadets about the mission planning. So there's our KML file by our OIC, Colonel Stephen Hamilton, KJ5HY. That's our Google Earth launch data. So you can see max elevation 80,000 feet. Last year, or 2 years ago, we had a max elevation of about 120,000 feet. But we had a heavier payload this time of about 6 pounds. We had our burst and then our descent over Monticello, right near New Paltz. And so some of the data overview that we had. So we tracked it the whole time with APRS. It made it very easy to track as we were driving in our car over these places with no cell signal. We had real-time reporting the entire time. It did never go above the altitude. We never lost it. And then each cadet vehicle also had APRS on it as well. We had a mag-mount antenna on some of them. And then Colonel Hamilton used his car as a digipeater to really get out the signal just from the weather balloon it was flying over. So we were able to get data just right off of the W2KGY balloon. So the most important part about our process was our build process. It was late March, about early April, we started really designing and building this balloon. constructing, testing, installing the launch modules. So there's some pictures there. Some of our underclassmen there that I had do the antennas and the rigging for the thing. It's really nice to be able to teach them about something they've never seen before, about ham radio, and telling them if you cut the lengths of the antenna, it'll be for a higher wave or a higher frequency. And then on the right there, we tested out a release mechanism for the balloon. It eventually got scrapped just for some pre-launch day worries, but we're looking to put it on soon. So yeah, those are our cadets building the satellite. And then here's our payload in total. So we had 7 total modules, and then our big thing was the time dilation study, a science experiment done. They presented it at the projects day that we had for our capstone, and they're planning to redo it in the future. So we had a whisper beacon put on there. We had a GoPro camera drilled through the middle. We had our slow scan television radio module, which I'm very excited about, and I'll talk about that soon. Our APRS radio. We actually used a phone charger for the entire power system because it had great battery life, and it was really good in cold-resistant conditions. And then I soldered up a central power distribution system to give out 5 volts to every single line that needed it. And they also had a Raspberry Pi that took images and captured data and altitude and temperature the entire time. And then on the bottom there, we also had yeast, which I'll show in a second, and then we had that time dilation step. The best way I can describe the time dilation is seeing changes in how time is recorded using relativity on the surface of the Earth as opposed to high altitude. The cadets who did this have published a lot of papers, and they do a lot of work in this kind of field. So here's this SSTV module I was talking about. So it was actually kind of just a stack of boards. So an Arduino on the bottom, a device called a Ham Shield, made by Morgan Redfeld. It was about $50 online, and it basically you could program your own ham radio transceiver, which was really helpful. And then on the top is an MP3 player on some proto board that I soldered kind of as a daughter board to stick on top. But it was a lot of fun. Its real purpose was to give us an approximate propagation forecast to see how well can we receive this amount of power from the balloon. It was about 200 milliwatts power, and we received it very well the entire time, which I was super impressed by. In the future, we're actually going to take live images from our Raspberry Pi and encode it into SSTV. And so you'll see it in real time, new images coming out about every 2 minutes or so. So what I did this time is I pre-encoded kind of that radio postcard you see, like the ISS does, on an MP3 file, and then I played it through the radio. All the code for that is available on my website. And it uses the Arduino Ham Shield. So there's a lot of frequency stabilization and timing kind of failures with that board. So we're going to move on to the DRA 818V radio chip in the future. But this board actually did work really well. We're just going to engineer more on size, weight, and power in the future. So here's some data on our Whisper HF module. It was called the Ultimate 3 and was purchased from QRP Labs for only about $30. It was really nice. 10 meters, because I wanted to have my antenna as short as possible for HF. And, as you guys all know, 10 meters was really active in the past couple months, so it was really fun to see how that was going to change. We wanted to see how the ionosphere changed and how the HF propagation changed with it over that 3-hour flight duration. The antenna that I ended up picking was a J-pole. It actually didn't work out so well because the 2 ends that I had come out would twist all over each other. So it actually was kind of ineffective. And our results kind of were less than favorable here, so we're looking to try it again soon. There were strict timing requirements, and the power that would eventually reset itself would destabilize the timing circuit, and then we wouldn't get any of that strict 10-minute frequency, 10-minute periods on the Whisper transmission. So we're just looking to revisit it, look at some other kits, look at some weak signal work, try GPS clock synchronization, maybe try an end-fed half-wave antenna as well. So I think that'll be really interesting and fun to put on there in the future. So here's a quick video. If you listen closely to it, I don't know if my audio is shared or not. So what happened there is we had the launch mechanism controlled by a DTMF dual tone multi-frequency tone. And so actually pressing 1 on my radio on a 70 centimeter frequency would trigger a servo that would release the balloon. So that's what we're looking to do in the future, is to have these radio controls all the way up to the balloon in case we need to cut our load. Like I said, this got scrapped due to concerns about the parachute attaching. We are looking to put it in the future. here's some more pictures. So like I said, we had the launch site at Salt Creek State Park near Scranton, PA. I strongly recommend you go visit there. It is the perfect spot I've ever seen to launch a balloon from. It's flat and about 3 miles in every direction, and then beautiful mountains on every side. And plus the landing will get you right to about New Paltz every time. So the key tests we had here were filling our helium, assembling the payload and launching. We had Cadet Bolin down there on the ground filling up the helium. So you can hold on to it still because it's only got about 6 pounds of pull on it. But there isn't really a good way to do it. So what we ended up doing is having those kids kind of parachutes that we strung over it and everybody would hold down to it. Because there's no other way to hold down the parachute. We don't want people touching the balloon in case it pops. You can see about 3 of our cadets, the Astronomy Club, Doctor in Charge, and then 2 ham radio experts on the left over there, all holding down the balloon so that it wouldn't fall off while we were filling it up. So here's a drone of us through this filling process. Video taken by Colonel Hamilton, KJ5HY. I don't think it's, yeah, there it is. Yeah, so that's just the perfect place to launch a balloon from. It's so flat and it's just beautiful in all directions. Okay, you can kind of see us down there. Just all the ground. So then came up our launch after we filled up balloon. We got some rigging. We taped down kind of the styrofoam shelf, got some rigging, and then connected it to the balloon itself with our parachute. It was nearly about 6 pounds, just under the FAA limits. So above 6 pounds, you need to register as a heavy and you need a license for it. Under 6 pounds, you're good to go. And if we ever go above 6 pounds, you separate it into 2 payloads that are less than 6 pounds each. And that's still legal. So that was our last photo that we took on the left before we released it. So you can see it is kind of pulling up. It is really ready to go. And then we just let it go. And it just flies wherever it is. It's APRS enabled, so we're able to track it from there. We all hop in the our APRS cars and just drive off and chase it. We do have forecasted landing zones. And we did forecast Monticello, New York. So here's one of our launch videos taken with the drone. Yep, and there it goes. It just takes right off. There's just so much tension built up around it. I'm always afraid that it's just going to snap off and we're just going to have a balloon fly out. But it always, if we rig it down well enough, it'll always take the parachute and the payload with it. Yeah, just a beautiful place. And so here's our actual launch video from the payload. Yep, and you can see the ends of the J-pole antenna too, and they just immediately got twisted. So kind of a disappointment there that we'll have to relook at, maybe with an end-fed half-wave antenna. But you can hear the metal elements of the APRS antenna whistling through the wind too. Yeah, it's almost dizzying to look out from that high up. So then we came into our chase step. So we all tracked it, like I said, with our APRS vehicles. Each truck had an APRS, so we all knew where we were, a good command and control strategy. But we also had a recovery team, I call them the goalie team, at West Point. And as soon as we said, we called them up, we said we launched, they drove out to where the landing site was, and they got there in about 30 minutes, as opposed to us driving out like 2.5 hours, the entire flight distance of the payload back. So they were able to catch it down there when it landed and not leave anybody stranded. There it is, like right when it took off there, that payload on the right, 20 feet off the ground. And then the recovery. So it actually landed at a family farm in Gardner, New York. right above Angry Orchard, if anybody knows where that is. So it was discovered by the daughter, Cassidy, and she was super excited about STEM. She totally said, she'd be joining her astronomy club in the future. She'd be launching her own payloads and balloons. But it was a great experience. They had horses and chickens and goats all over there. So all the cadets got to see that as well. But the family was super excited about the payload. We were all super excited that we landed and everything was intact. We were able to get valuable data off of it. But it was just a great operation overall. So here's our next steps. So we have a tethered launch that we're planning next fall. We're going to launch it off of one of our range towers and just tie it to the top and leave it up there for several hours and do some more studies. I'm looking to put a crossband repeater on there. I'll let everybody in the Hudson Valley know about what frequency that's going to be on so they can key into it, and we'll maybe have a special event station going on. We're also going to do a fox hunt. It may be internal to just cadets. We may invite the ham radio community out to participate. It'll be in November or March, or both possibly, depending on our triathlon schedule and how that's going to work out, and how COVID works out with visitors too. Now, we'll also be N2D on Constitution Island on 12 June. We'll be activating it for the first time, making those 15 contacts to qualify it. Our club will have greater participation, Hudson Valley Digital Network. I think I have to say that because I'm here, but definitely with the fox hunts and all that, we'll be happy to participate more. Now, me personally, so I'm currently making some SOTA antennas to take with me. I'm going to Boulder over the summer to do some real SOTA work and to work with the CU Boulder. I think SOTA takes #1 here. I'm usually on 40 meter CW during the weekday. It is kind of boring, but I really like it. I really like Morse code. I like chatting people up. So I have an Elecraft, and I'll be able to take that up there. I'm also 3D printing an iambic paddle with a leg strap. And then I'll be able to do some more SOTA work next semester when I'm able to lead. And maybe interact more, go to some Orange County Club meetings. And then further goal for me, so I am looking to join the Cyber Corps of the United States Army and to do some radio direction fighting and jamming in that branch, to be a cyber electronic warfare or electromagnetic activities officer. The MOS for that is 17 Bravo. And then I'm hopefully trying to go to grad school also after West Point, either Georgia Tech or Stanford or Boulder maybe for the electrical engineering programs. So yeah. In the future, you'll see crossband repeaters, some improvement from the SSTV, and HF tents, all in a tethered launch. It's just super passionate about ham radio here, a great integration with the military. And we're all able to just center focus and push on our balloon launches, which are wildly successful. So those are OICs for Astronomy Club, the CICs for Astronomy Club as well. But yeah, thank you all so much for listening. I'm happy to take your questions right now.
Well, firstly, Nolan, thank you so much for such an excellent presentation. You covered a lot of ground, probably almost as quick as the 434 meters per minute as the balloon. Thank you, Colonel Hamilton, for sharing that data point. So, again, really fantastic presentation. There were a few payloads. I guess I'll start off with a couple of questions, and then, if anyone wants to type some things into chat or raise your hand, I could, open the floor to let some other questions, and we have a fair amount of time to run through it. But maybe one of my first questions is the wet yeast. Considering that you landed not that far from Angry Orchard, are there any plans to propagate that wet yeast into some type of adult libation, or what could you tell us about where is that yeast going to end up?
Yeah, so totally. Colonel Hamilton, actually, our OIC for the Ham Club, he's a microbrewer, home brewer also, and he put the yeast on there. He's definitely planning on making a space beer out of it. He said something about the radiation when it gets up to the high altitude. There's more radiation up there to ferment the yeast. He has a control yeast, wet yeast, and then a space wet yeast. He's done it before, too. He made it out of dry yeast that he sent up a couple years ago and had it at one of our first-class cadets commissioning ceremony. So it is our chance. He does like to brew it. I'm excited to see how that's going to turn out.
Well, that sounds like fun. I'm not a beer drinker myself, but I know there's a lot of people, especially in the Hudson Valley, into micro brewing. So maybe this might inspire them to try a few different things, or if they go to one of the many places where you can consume such beverages, to look for something like that on the menu. I know there's quite a few companies that do small batches on that, but to know that somebody locally is actually doing that themselves. That's taking, no pun intended, micro brewing to a totally different altitude, I guess you could say. But
Right.
but very, very good. Maybe another question for me before we open it up. And again, everyone on the bottom of your screen in your row of icons, if you click the little hands button, that'll allow you to raise your hand, and then you can take yourself off of mute and go ahead and ask a question. But I guess my second question is, on the time dilation, I know it's a very, very complicated topic. I know it's very important to different types of navigation, but do you want to maybe share a tiny little bit more detail on time dilation?
Yeah, I can share as much as I am comfortable talking about on 1 foot. I think we all know Einstein's theory of relativity that says time is relative to its location of some sort. They thought that time would dilate when it was up in the upper atmosphere, that it would compress. So they were looking at waveforms, kind of, I would think a clock signal is the experiment I saw them doing, is they would look at a clock signal for hours long and look at all the clock pulses in it based on a chip scale atomic clock, which is, they'll actually have those on CubeSats as well. And then they took it up to the atmosphere and measured the same clock pulses with the same clock and saw where those clock pulses align at to see, like, well, they were an eighth of a nanosecond off there, see what happened. And I think they actually found that it went in the other direction than they planned. And so they're still crunching the numbers on that. They will be presenting at a small satellites conference in the summer, but they'll be continuing to work more and hopefully having on that tethered balloon launch where they can keep it up there for hours, maybe even 24 hours at a time, to really see how that's going to work at that high altitude. And I think that's about all the extent that I can tell on 1 foot about the time dilation project.
Well, I think that sums up a very complicated topic. So yeah, any types of inertial navigation are very important. As a globe, we got a little too used to just using GPS for certain things. And so, having that research done certainly is super important. So very, very cool. So let's open it up. Let's see who wants to be the first to ask a question. I really hope with the material that we covered, there's some good questions in there. So if anyone who's like a former faculty member of USMA or citizen scientist or whoever's in the audience, please go ahead and take yourself off of mute while we have Nolan. And we also have representation elsewhere, such as Colonel Hamilton lurking out there. So if you have a question, take yourself off of mute, and let's see what the audience has.
I'll ask something that someone may not ask is, what was the most challenging thing, Nolan, you being the CIC? I know that every time I've done a balloon stat, they're incredibly challenging. So I'm curious, from your perspective, what is the most challenging part about the whole experiment?
Yeah, sir. So I think the big thing there was managing and understanding that deep of a level rooted of every single payload, but still having that broad overview of being able to synthesize in a system. Especially, because I designed and tested and built 3 or 4 of the payloads modules. And so having to tell somebody like, oh, this is exactly what it does, and dig into the tendrils, and then still being able to manage at that top level too. I ended up actually just telling a cadet who was maybe an econ major or maybe a business major, like, hey, you're in charge of the APRS system. Go learn everything you know about APRS, because this is now your system and you're responsible if it fails. Just throw them in the fire there. But they learned about it and they really enjoyed it. And some of them are going to get licensed because of it. So I really found, just give them the responsibility and they love to help out. That was really the best way to do it.
All right, looks like Eric, KD2TAQ has a question. So Eric?
Yeah, I'm just curious what altitude you expect the tethered balloon to reach.
Yeah, so that is relative to the line that we have. I have been looking at, Boulder has done some, Minnesota and Wisconsin universities have done some as well. They reach about 10,000. So we'll have to factor in, or no, there was one in Maryland I know that just had 1,000 feet elevation from their relative location. It's just based on that line length. We'll see how that works with the chip scale atomic clock, if that's going to affect their time dilation at all.
Thank you.
Yep.
All right, we have a couple more minutes for some questions. Don't be afraid to speak, or if you'd rather type them in. We're looking at both questions coming in on the Jitsi chat, but for those that might be joining us via the YouTube live stream, I'll rely upon Neil W2NDG to translate any questions typed in on the live stream over here. Anything coming through on that, Neil?
Oh, Neil, I think you're muted.
Of course I am. Nothing yet. I'm going to take a look here.
So while Neil's looking, he runs a relative new weekly science and technology chat for the Overlook Mountain Amateur Radio Club, which is, of course, here in the Hudson Valley. Last night's topic at one point touched on quantum, which covers quite a lot, but quantum is very much aligned to a timing topic. So I didn't get a chance to listen to the whole replay, Neil, but did anything relative to time dilation and quantum come up on last night's net?
One of the things that came up, and one of the reasons why I was thinking about quantum technology, was that there was about a month ago, there was an article that came up in one of my news feeds that somebody has decided to apply quantum theory to software-defined radio. And in theory, what they're saying is they would be able to capture the entire radio spectrum from 10 kilohertz through about 5 gigahertz in one shot, and then process it afterwards. It was just interesting, and it got me thinking about quantum technology and actually looking into it, because those of you who may not know, IBM has picked Poughkeepsie as the site of their quantum center. So it kind of puts things right in the Hudson Valley, and something I definitely want to get a better understanding of. So I read what I've learned so far and then threw it out to the group. And then we discussed the history of computing and how, as Moore's law appears to be approaching a physical end at some point, other technologies like this are going to take over and allow us to continue and keep growing. So
fantastic. Yep. A lot of times people think of quantum. It's not just quantum computing. There's quantum encryption, quantum security, and quantum communications. Most of those touch on my day job. And then speaking of Poughkeepsie and quantum, Joe Apuzzo, N1JTA, who's one of the co-founders of HVDN, just so happens to be a quantum lab manager at the Poughkeepsie site. So he was gracious enough to take me on a tour one day, and that was quite a interesting experience to see that up front. So very, very interesting things in terms of time dilation and quantum. I did see ever so briefly a little indicator blink. I think somebody either came off mute or raised their hand or something, but if there was another question in there, go ahead, share your name and your question.
Oh, sorry, that might have been me, I think. I clicked on this. No, I was just thinking about that. I read that same article a while ago, a few months ago, I think, about the SDR and pulling in all that data. And I was at the Johns Hopkins Storage Lab before I came here. So my big concern with that is, okay, fine, if they could be sensed, that's one thing. But how in the heck are you going to pull the I/O off for that? I mean, even like 20 megahertz bandwidth, if you're storing 60-bit samples, you're talking about like huge amount of bandwidth to be able to store that data. So I think that's if it can be sampled using quantum technology. I'm still not. I can't wrap my head around how we could just transfer the data to a medium that could be analyzed for later. So I don't know. That was just my thought on it.
Well, there's definitely a lot of applications for it that, certainly makes sense for like a whole separate range of conversation. But, it's good to hear that it's capturing everyone's imagination and, think about it. By the time it makes it to our eyeballs, there's been folks in academic labs, studying this for quite a number of years. So what makes it to us, just imagine what they're already working on that hasn't made it to us yet. So lots of interesting things. And then from a space perspective, there's a lot of major benefits through quantum and also other types of alternative navigation that are going to be needed for long duration and long distance flight controls. So U.S. Space Force, of course, is one of the many arms that's looking at that. So certainly I'd love to find some people that could maybe share a little bit about the quantum communications side in the future. So let's see. So we're coming up on 8:43. Really trying hard to get some questions. I know they're out there and somebody just needs to speak up, but maybe there are some questions, I don't know, on the slow scan television. I know myself, I was sitting in my car during the Overlook Club's Fox Hunt that day, and our hopes was to actually have a few of the USMA cadets join us, but because the launch window got moved up, we found the Hudson Valley having two major events, both on the ground and in the air, happening at the same time. And so I was sitting in Kingston waiting for a CSX train to go past, and I was recording the signal coming from the balloon. And I think one of the images on your slide, Nolan, was that one of mine?
Yeah, that was yours, I think.
Yeah. So one of the things that was kind of interesting was, so I'm sitting there with my fox hunting partner, Charles, and I have my cell phone, held up next to my speaker of the radio in the car, and it's just pulling the image down real time. I did 5 or 6 image decodes, and it kept chopping it off at the bottom. And then when I got home and shared those details with Nolan, I saw other people had the same results. And so wasn't there something that you changed with the code due to the timing? I think that's what you mentioned about the module, the ham shield versus what you're going to be moving to in the future. So I don't know if you could share a little bit about that, because timing is super critical, with all this. So anything on the code? It looks like you're about to share something interesting. So,
yeah, I actually don't know what happened there. Let me try and fix this fire real quick. Oh, there I am. Okay. So the code actually, if you remember, the ISS on heat, or to dissipate and manage heat. All right, well, I'll show that. To manage heat, the ISS does it in 2-minute windows or so, and then cuts it off, and then turns it back on every 2 minutes or so. So I had it on a 30-second transmit and then a minute rest cycle, and the image was 35 seconds long. So it cut off the last 5 seconds there every single time. That was just an oversight on my part. So we'll improve it next time and manage it a little bit better. I think I used I think I was using Scotty or something instead of Robot 36, which let the whole thing through, and then changing to Robot 36, cut it off at the bottom. That's just an oversight that I'll fix next time.
Got it. Perfect. Yeah, I know in the past when I've decoded slow scan coming off of the space station, after the signal is done, the carrier still stays open before it drops out. And so I have a couple of those recordings on the HVDN website. If anyone wants to try it, you can just download the MP3 recording and hold it up to a cell phone, or run it through some other audio pass to see what it is. But I'm super excited to see the next iteration of this. Those DR8 modules are really neat. They are basically the basis of a analog transceiver, and with a few little extra components, you can make a full-featured transceiver. There's one guy, let me think his call sign, K8LID, who's one of the AMSAT folks.
I think it's W8. W8.
Sorry, so Whiskey 8 lid. He's taken 2 of these and made something kind of unique, a QSL card. He sends that as his QSL, and then you solder on 2 of these plus a microcontroller, and it makes a QSL card sized crossband 2 meter to UHF and vice versa crossband repeater. So, you know, maybe that's your inspiration for the crossband or otherwise, but definitely that's an interesting module to design around. So I'm looking forward to that for slow scan as well as crossband for next time.
Right. Yeah, absolutely.
So, quick question from me, W2NDG. I was curious what hardware you're planning on using for the crossband for the next one.
Yeah, so we are looking to integrate those DR818D chips. And actually, I've done a lot of research into this to keep it either on 2 meters the whole time or to switch over to crossband. If you do it on 2 meters, you need these giant radio cavities. People use cake pans for them, but usually they're giant brass rods. We think that'd be too heavy for our uses as a repeater, so we are going to look to go to crossband. And we're thinking there isn't a need to reinvent the wheel. We could just use W8 Lid's design and just put it on our system and have a whole crossband repeater with those DR818 chips on there. That's what we're thinking in terms of hardware. I may iron out the code to do something a little bit different, but that's the direction we're pushing towards right now.
Okay, and I'm assuming, well, SSTV makes sense from a point of view of computing power, but is ATV even possible on something like this, or is it just too much heavy lifting, if you pardon the pun?
Yeah. Yes, I think Steve could also talk about that. We were looking to put that module on there. I have a satellite receiver, and I have GNU radio with the DTV on there, DVB S2. We abandoned it because I was still trying to use an Edis 310, which is like 10 pounds or so, and I didn't think I would get my weight requirement down in time to put it on the sat itself, and then the directionality of the antenna too. I didn't really feel like sticking a Yagi straight down to have it snap in half when it lands, because we did that one year. So if Steve wants to talk about anything about digital TV on a balloon sat.
Yeah, I could touch on that really quickly. There's a club in Australia that's done something really interesting recently using DATV, and it kind of inspired me as part of a project that we're hoping to do through HVDN with our own balloon, and we'll start with a tether and then do high altitude. But one of the payloads that I wanted to do is a 1.2 gigahertz DATV transmitter, and my hope was to use a Lime SDR Mini because it's small. It only puts out 10 or so milliwatts, so it's very low power. One of the things that I learned with a imported 1.2 gigahertz amplifier is the amount of weight and heat dissipated is definitely going to increase the weight of the payload. Not really by that much, but the cost starts to get a little expensive. And so with any balloon launch, you always have to run that risk of losing your hardware. And so the funny thing is, one of the local stores that we have here in the Hudson Valley, recently I was there and they took a new load of stuff and I found something in a box, and it was probably the best deal of the century. So there were 2 brand new, let's see if I can get it, there you go. So 2 brand new in a package, Hacker F Blues. So I've since customized it with a 3D printed acrylic case, but even though this is a lot larger compared to the Lime SDR Mini, this is a full-featured SDR transceiver. And it literally cost me next to nothing, so I don't really care if one of them goes missing in the ocean or something. So one of these is definitely going to find its way into some type of a balloon type of project. So that solves one major hurdle in terms of low-cost hardware. That's going to be fun. So we can chat about that, but yeah, DATV is really interesting. And again, it's a little expensive to do, but if you can find low-cost hardware, such as I managed to do, that solves the problem. So we'll post a little bit more about that on the HVDN blog, and share a couple other links to some other projects that have done DATV. But DATV, for those that are not familiar, it's digital amateur television. There's different standards such as DVB and DVB-S2. which are used for free-to-air satellite. So there's ways that you could remanipulate that and use that for terrestrial transmissions. And so you basically get, in my experiments, you can get a full H.2.64, high definition video stream in about 500 kilohertz of space. Whereas compared to if you were to do like 30 frame analog, you're going to take up between 2 to 6 megahertz. So it's really interesting what you can do resolution-wise with such narrow bandwidth with DATV. So DVB-S2 is what I've been experimenting with. But if anyone wants to learn a little bit more, again, I'll share some further links and stuff on the HVDN site. I knew I'd get you out of the woodwork, Eric. So question, over to you.
Mom is. Yeah. Oh. Yeah, I'm curious to know more about the time dilation experiment. Thinking about how you would do that, there would need to be a reference clock on the ground, same model and everything. So you did that.
Yeah, so it was actually quite a process with them. The power module for us was just that phone charger that connected all of my kind of ham radio modules. They had their own little box with their own lithium-ion battery, and they kept it running continuously without a clock reference. So, they came to the site with their little styrofoam box and put it on, and then took it off and kept it in the car with them on the way home.
Okay. And you say they got the opposite effect of what they expected?
Yeah, that's correct. I'm assuming dilating means that they compressed it and they actually saw it lengthen. So we were going to try and argue some flat earther conspiracy and get money that way or something.
No. I've actually looked into this.
Okay.
Because I'm a physicist. So when I heard that GPS satellites were affected by relativity, I didn't believe it. So I went and worked it out myself. But I got the time delay first and got it wrong, and then I went back and corrected it. I want to actually know the board on this, because I'm at SUNY New Paltz now, and we're getting a balloon program going, and I'd love to send up a similar mission. But in time dilation, there are actually two effects, and they compete. There's the speed effect that from special relativity, where the faster you travel, the slower the clocks appear to be. It's all about appearances, relative to another clock. But there's also the gravitational potential well effect. And the clocks get slower the farther down you are in the gravitational well. So, for example, falling into a black hole, you get a red shift, and clocks appear to go slower to an observer outside. So that means if you're going up from the surface of the Earth, the clocks will appear to be moving faster due to the gravitational potential. There's actually an altitude where these two effects would cancel, and it's not the altitude that GPS satellites travel. Although they considered doing that, and instead they just steer the clocks and report. Actually, the clocks actually report what time it should be on the surface of the Earth, not what time it really is on the satellite. So that when you in a slow-moving balloon compared to a satellite, I would expect that the effect would go the other way due to the gravitational potential.
Yeah, that's all really interesting. I'll have to put you in contact with those time dilation people.
Sure.
Yeah. And they still work on it. They're working on it now. They're working on it over the summer, and they'll work on it next semester. Okay,
maybe I can get info from them. I'd like to know more about the actual hardware that you all use, because I may try and buy some.
Their big thing was an atomic Raspberry Pi, that they had to scale that in their chip scale atomic clock. But I think I do have a copy of one of their papers, so I can send that over.
Okay.
All right. Well, sounds like we have another thing to decide on, Eric, for Balloony Tunes.
Yeah, exactly. No, I have an atomic Pi, but it's actually that's actually a small microprocessor. I don't think it has anything to do with being an atomic clock. But,
yeah, I'll send you what they had for their chip scale. They have everything in a kind of process document. So
okay, great. How do I get my contact info to you?
I'll get you guys in touch with
Do
you.
that? Okay, thanks, Steve.
Perfect. Well, again, I would like to thank Nolan. I guess N2WU, since we're getting ever closer to tomorrow. So congratulations on the shorter but equally hard to say call sign, at least if you're doing voice. But on CW, N2WU is actually
so much easier. Yeah, it's very nice on CW.
Quite a good one. So thank you again for the time and the excellent presentation. For anyone, if they'd wish to watch the replay, they can do so on the HVDN media channel. It'll also be cross-posted on the W2NDG Science and Technology channel that we're trying to grow. So a couple places for you to find it. And again, thank you so much. We'll call this an evening and a successful presentation. And again, hopefully everybody enjoyed. Thanks and have a great evening, everybody.
Yeah. All right. Thanks, everyone.
All right. Good night.